So basically the next talk will be a generic lecture on how to collect and process the data in eSports, and probably it would be quite interesting hint for you where to apply machine learning stuff and how to get new results, new research, and publish new papers. So basically my talk will be divided into a few parts, and first I would like to introduce you the concept, the definition of eSports, and provide quick facts. Then I will present you what is eSports player, what is a training team, and basically we'll start with the problem definition, what basically is the key problem in eSports right now. Afterwards, I will provide you with information on how do we conduct research on eSports in Skoltech. After that, we'll switch to data collection and processing. I will touch upon different sensing technologies and demonstrate our results on eye tracking, keyboard, mouse processing. And finally, I will report on design and implementation of real-world experiment. So basically, eSports sometimes is referred as a computer sport and electronic sport, and if we try to provide a definition, eSports is an organized game where single players or teams try to compete against each other for achieving specific goal by the end of the game. And by the way, eSports is recognized as a sport in Russia and worldwide. So in Russia it was recognized as a sport 3 years ago, and in many countries such as Korea, European countries, it is recognized as a sport as well. And by the way, eSports in some countries like Sweden and South Korea is taught at the schools. So kids and child try to learn how to play different games, for example, Warcraft. Right, and let's try to define why is it sport. So first of all, it is a sport by definition, and if you would like to have a look at the formal definition, you can refer to this organization. But in general, since there is a competition of teams and individual players, since it is not harmful, since the players use some tools for playing games, so it is recognized as sport. The second point is that it is highly competitive right now. So millions of players play computer games, and there are different disciplines like shooters, like simulators, like fighting or card games. So, and basically those players who play these games like at amateur level, they would like to become professional players, and that is why it is highly competitive, and we will have a look why. Another point is that eSports is characterized by professional attitude. If you are a professional eSports player, it means that you have to attend the trainings and have a professional regime. So you have to follow the schedule, you have to sleep well, you have to collaborate with your teammates, etc., etc. So it is a professional lifestyle. And another point which I like best of all, so eSports sometimes is considered as the chess of the 21st century. And the point is that the context in eSports changes quite fast, and you have to take decisions, and eSports basically develops your analytical skills and ability to think and predict the situation a few steps ahead. And if we try to compare sport and eSports, basically eSports has some features. So first of all, physical development of athlete is at low level comparing to normal sport. At the same time, it is characterized by high speed of decision taking in non-standard situations. And if we consider team sport like football, like competition and tournament like Champions League, and try to compare with eSports, basically the situation and context changes much faster in eSports rather than in professional football. But at the same time, there are some similar points between eSports and sports, so players basically exist in both natures. As I said, they attend the training sessions and follow their professional lifestyle. As in typical sport, the disciplines include team and individual games. At the same time, they have to perform logical thinking, and teams or individual players, they compare intellectual abilities of each others. And basically, eSports appeared just a couple of decades before, I would say, at professional level, and the evolution of eSport players is as follows. You can see it on the slide. So everything started from amateur players, and those guys, those school boys, they just simply wanted to have fun and enjoy playing the games. And after that, a hardcore player appeared. That means that a team or just a player, he wants to win. And this is like an important step towards professional player. And professional player, so he wants to get and achieve the results, and now it is a job. So that's the main point. And you can see that this slide basically shows the behavior of non-professional players and just professional athletes. And for the moment, eSports, it is not computer gaming, but also big industry, big money. And however, if you first time attend professional tournament, I think you will be shocked, because one of our colleagues said that he attended one of these tournaments in the United States, and he was really puzzled when he saw thousands of people which come to the stadium, and they saw just 10 players sitting in the middle of the stadium and just playing computers. Right, if we have a look at some market data, you can see that huge money has been spent in eSports yearly. Millions of people, not only players, but just normal people, attend professional events in Europe and United States. There are lots of viewers and enthusiasts which come to different tournaments and just have a look how it happens. And if we have a look at the money and prize pools, so you can see some figures on this slide, and basically the prize pool for Dota 2 World Cup 2 years ago was nearly $25 million. And by the way, this year, this prize pool will be already $32 million. So you can see that this gap and the prize pool basically improves a lot. Right, and let's have a look also at industries, and you can see that gaming and eSports has progressed a lot and even has bigger market comparing to television, and I don't even say films, movies and music, so it's quite huge right now according to New Zoom statistics. And let's have on the market inside eSports. So basically you can see that there are different directions in eSports. It is about communication, it is about marketing, it is about hardware, when people design and implement specific keyboards, headphones. So it's about broadcasting, and basically people which perform broadcasting, they typically earn money for advertising and donations. So there are lots of publishers, developers. However, the most promising direction is basically training and analytics. And the number on the right bottom side shows that also more than $2 billion have been spent 2 years ago on contracts within this area. So let's now switch to players and teams. And so what is the definition and who is eSports player or sportsman? So basically it is a player which participates in semi-professional events quite regularly. And as I said, most of these players would like to become professional players. And the professional player, in turn, is a sportsman which gets the salary. So he has a contract, and according to this contract, he has to follow professional lifestyle. So that's why he is very focused on the results and wants to achieve the final goal. I presume that there are lots of questions. What is the age of those professional players? And basically the average age is from 16 to 26. And within this period, those professional players try to get the prize pools, money. However, there is also, the backside of this money and tournaments. So basically, after finalizing their career, they don't have any diplomas, they don't have any background, and they don't have profession. So they are esports athletes, and that's it. However, many of those players, they typically switch to training or manager positions in the same area and remain like in the professional teams. And by the way, we have at Skoltech some ideas, and we will try to organize also courses on esports, on how to process the data, on how to collect the data, probably next year. Because, this is the profession of the future. We think, we hope so, as data scientists, so it's like another interesting point. Because in Russia and the teams worldwide, they typically ask whether you could prepare the students which could have background in esports, whether they could be helpful in this industry. And basically we will try to do this attempt quite shortly. And what is necessary to become a professional esports player? So first of all, you should have a specific talent in esports. For example, I was playing Counter-Strike and other games when I was a schoolboy. However, I didn't really have a talent. But at the same time, it is not enough. As I said, it is important to perform and follow professional lifestyle, have trainings, and also to have some luck during tournaments. For example, if we just have a look at some esports players, so here it is an example of esports player, Russian player, Roger. So during his interview, he said that his parents didn't like that he was spending lots of time playing computer, but afterwards there was a professional tournament somewhere in Russia, and his team won the prize pool, the first $1 million, and his part was 200 rubles. I think it was in early 2010, something like that. And as he said, his parents, after this achievement, allowed him to continue playing games. Another success story is about Dota 2 discipline and OG team, which won the international Dota 2 last year. And basically why I decided to discuss this team is because they actually were absolute underdog. They were not considered as potential winner of this competition because, well, they actually changed, they had to substitute 2 players in their team right before the tournament. Also, one of their players did not have experience in professional career at all. They had very tough qualification. They will, you know, nearly leave this cup just a few times, but finally they managed to win, and it was like, you know, winning of Leicester 2 years ago of English Premier League. I don't know if one of you is following football in the UK. Let's have a look at eSports team, and basically a typical team should have some essential points. Of course, they have to be equipped with professional players, and now it is also in the market. Players can change the teams. They can be sold to different teams like football players. There should be a captain which represents the interests of the team, and basically this should be a really experienced guy who will be able to manage and guide the team during different situations during competitions. And typically there is a coach which performs basic analysis of the game, and basically which performs the scheduling and manages the team. And the optional stuff includes a manager, which basically helps to buy, you know, tickets, book everything regularly. Sometimes there are psychologists and even cooker. And in terms of professional training, basically, for example, if we have a look at Counter-Strike training, basically there is individual and team training. And these exercises and training, they switch one another during the day, and all teams, they have their own approach, but let's have a look at the approach of our team, which is located in Skolkovo, on territory of Skolkovo. So typically the training starts with wake up and physical training, and is followed by warming up with the mouse clicking. So then there are some simple exercises on the reaction, and next they perform training game. So after having lunch, the team typically starts with the theory, where they discuss the philosophy of the game, the tactics, the strategy, and after finalizing this discussion, they basically start main training, which is the main game, and they try to work on what they have just discussed in terms of strategy, tactics. After that, they have a short break and have an official game. Typically it is in the evening or sometimes during the night time. And finally, if they have still some spare time, they can perform get together and summarize what they have done during this official game, whether they met their goals and requirements of their coach. Right, and so in terms of important skills, what is important? So basically, first of all, this discipline is a team game, and what is important is to have very good communication skills. So the team speak metric is highly important. And when you try to analyze a team speak of a particular team or particular player, you can easily say whether this person had professional experience or not. And why is it important? I can just provide you one example. So last autumn, nearly a year ago, there was cup of mayor of Moscow, and 2 schoolboys won even professional teams. And when we started to analyze what has happened, basically we realized that they had very good communication. So they discussed efficiently their strategy. They did not bother each other. They just tried to do everything peacefully, and finally they become the winners. So another important metric is reaction time, which can be measured and identified by eye tracker. I will have a look at it later. Another metric is work with aim. And I would say that aim is not the most important metric, because it can be trained within 1 or 3 months, and it is not helpful within a long period for teams. So if you train communication skills, it is much, much better for professional teams. And another point which is very, have impact on the team is willing to win and so-called sport aggression, because in professional team they all have contract and they have to do the job done. And basically, what is the main problem? And currently the problem is that there are no available tools for the eSports professional coaches to assess physical and mental conditions of athletes. And the challenges basically are as follows. So the point is that typical games, they provide very simple statistics. So who killed how many players, what is just your account, and the point is that there is a lack of a visual aid, and basically it is essential for players to demonstrate what is the best direction for further development and their progress. And all teams, they lack visual feedback, because basically those guys which play esports, it's quite hard for their coach to explain sometimes why they do not perform well. So for example, he might say, okay, I'm shooting very good, and why I'm not the best, why better teams do not engage me and they do not hire me. And when you have, quite good graphs or heat maps or whatever, you can clearly say, okay, so this is your problem, try to improve this skill, try to work, let's say, on reaction time, or try to work better with your keyboard. So this is much important for them. So another point is that in terms of analytics, we can provide information on their reaction time in stress situations. For example, clutch. And clutch is a situation when one player remains against a few players from the opposite team. And here you have to define what is this player who can play against many of them, and whether he has an opportunity and chance to win. And this information, this analytics, can be highly important for coaches. For example, if you still have 2 players and you need to kill sniper, you could infer which player is not that important for clutch, and just keep the player for clutch, which will provide you the most efficiency and with high potential to win. Another point is to perform the analysis on, for example, warming up time, because prior to the game and tournament starts, each team has 1 hour for warming up, and you could say to your players what is the best time for a particular player, whether he needs all this time or just half an hour. And finally, what is important is the distribution of psychological resources, because each tournament is a very stressful situations in terms of mental stress and physical conditions as well. So let's just discuss what is about eSports at Skoltech. So we have our own CyberAcademy, which was founded 1 year ago, 1 year and a half, in 2018, and we perform research in different directions. For example, on trying to understand psycho-emotional conditions of esports players. Our colleagues Andrzej Cichocki and Professor Fan, they try to do research on EEG in the direction of brain-to-brain compatibility. Also, we work on building eSports datasets. Apart from research, we have also a professional team, Monolith, which specializes in 2 disciplines, Counter-Strike and Fortnite. And by the way, we have male and female teams. And by the way, female team is much more professional comparing to male team. So we also work on innovation, and we have 2 startups within Skoltech. And our research group on eSports includes 6 persons at the moment. So it is myself and Evgeny Burnaev, one of chairs of this summer school. So I'm involved in sensing technologies, and Evgeny works more on data analysis. So I presume you have already met Andrei Langi, who also works on feature engineering. Anton Stepanov helps me with sensors and architecture design. Dmitry Nikolaev also works on software engineering aspects and machine learning. And Alexander Korotin also works on data analysis. We have a couple of grants and started our research nearly a year ago, and both grants are about the same things, more or less. So we try to carry out research in the direction of understanding of psycho-emotional conditions of professional esports players, and luckily we have this opportunity to work with professional players. So this year we also started a startup company, KRAKEN, and this startup is about designing a platform for collecting esports data and providing visualization with analysis of psycho-emotional conditions of athletes. So here it is, a couple of links for our Instagram and Facebook, where we try to post recent information. Right, and also have a web page shown on the right up corner. Right, so the next slide is about our publications. We managed to publish 6 papers, so you can take a picture, or if you're interested, I can provide you the copies of our papers. And last week, we also got the Best Paper Award in Leicester in the conference called Internet of People, where we presented our smart chair, which with feature engineering aspects. So now let's try to move to data collection and processing part, and let me remind you the key problem that there are no tools for performing the assessment of mental and physical conditions of professional players. So, and now the point is whether the sensors can help in this assessment. So nowadays we have lots of sensors which can be wearable sensors or any kind of unobtrusive sensors. However, there are also, sensors like EEG, measuring your brain activity. Sometimes you can find the papers on researchers trying to perform the blood analysis, but we do not typically follow these situations, because since we have a startup company, we try to work mainly with unobtrusive methods. And our solution is to design a cloud software as a service solution, where each team will be provided with a set of sensors. We will perform the analysis of physiological parameters, context, basically what happens around the player, what is the temperature, humidity, what is the noise level. We'll also perform the analysis of game telemetry, psycho test data as well. So basically the system will study the behavior of each team member and provide individual advices for training and for competitions. So here it is, the experimental test bed designed by our eSports research group, and as I said, we have basically three groups of sensors. So this is physiological sensors on the right side of the slide, so where we measure the position of eyes, heart rate, skin resistance. There is also contextual data, so it's about environmental data like CO2, temperature, humidity. And by the way, when we deployed our environmental data in eSports camp, our coach and manager, they said that even this environmental data, they have a very negative impact on the results, on the performance of the players. And first of all, a bit, puzzled that, okay, the changing of temperature, humidity, perhaps it is not that critical. But when we attended professional tournament on the 10th and 11th of August, we really realized that this is, highly important. Not only physiological data, your heart rate, but also what happens around the players. And finally, important information which we collect is game telemetry, basically the information from your keyboard, which combinations on your keyboard you typically use, your mouse movement, what are the typical patterns, how often do you, when do you need break while using the mouse, and many other important features. And so another question is basically what to do to connect and synchronize all these sensors. So that's quite important practical problem when you start working on the experiment design. So and here it is, our experimental test bed for synchronization, where we have all necessary sensors, we have our Wi-Fi router, we have game server, and typically there are two strategies for synchronizing the data. It is real-time synchronization and post-synchronization. Right, so for realizing real-time synchronization, basically there are two options which we were considering. It is using the precision time protocol, which is characterized by high precision. However, you pay for this pretty high cost in terms of power consumption. And at the same time, there is also network time protocol, which is a bit lower, but still acceptable, lower precision, and has low cost in terms of resources. And for the NTP protocol realization, there is a set of requirements. So basically there should be a wide network, there should be local NTP server, and it also allows for adequate load of processor. Okay, so in our system, in our test bed, we realized the server using lab evaluation board, Raspberry Pi, and this board takes the precise time from GSM and provides a pretty good time accuracy from 1 to 10 microseconds. And this is important for us because for us the main limit was roughly 50 milliseconds, because why this time? So this is the time period when a human cannot hide his emotions. And this is important when you use a video camera. So when you have your sensors working with this time limit, so if you can perform your measurements within 50 milliseconds time period, this is perfect. So and in our test bed we have a number of clients with different types of sensors, analog sensors and digital sensors, and we also have a game PC where we were collecting our game telemetry. However, we had to do some tricks with the registry and set it up properly. So here it is the picture of our testbed used for synchronization, and here it is the graph showing that we have real-time accuracy less than 10 milliseconds. So basically we achieved our goal. So, but for post-synchronization, when you have already collected your data, you also have to synchronize your data so that you could ensure efficient processing of those data later. And basically there are so-called demo files. Basically it is video files with the game, and those files contain all information about the in-game data. And the point is that demo files, they are not connected with the real world somehow. And there is a problem of synchronizing of game log with the system. And so basically we proposed an algorithm for performing the synchronization of the game log with other sensors used in our system. And our main idea is to synchronize the event data of the game log with the mouse key pressing of the player, and for which we know the exact UTC time. And basically from this log of the game, we know all the ticks when the player shoots from the weapon. And at this moment, the player must have pressed the left mouse button. So basically thus the problem reduces the finding of the best match of two binary time series. So the player fire event from the game and the left mouse button pressing indicator. And our post synchronization accuracy is around 3 milliseconds, so even better. Right, so let's move on to data collection, and let's have a look at typical challenges. So first of all, you need professional data for different classification tasks, and that is why you need active professional data from professional team, and that is why we collaborate with our monolith team from Skoltech. Another challenge that the data are highly heterogeneous. So you can have video data, you have different data from various sensors, and by the way, you also have different methodologies for collecting the data, which is another important point. And the third point is that it is like a black box generated game data, because the logs are typically generated on server, and you need the access to this server. That's another practical aspect. And for the sake of ensuring equal experimental conditions, you should also ensure the same scenario played during this experiment. Right, so here it is, the second slide on data preprocessing challenges. So as I said, there are different data streams. The data could have noise, either from the environment or from the human itself. So you have to store them correctly in the same, preferably in the same data format. So there could be, some problems with incorrect exploitation of sensors. Right, and finally there is a problem with in-game data format generated by the engine. And the data essence depends on the game. So basically when you conduct the experiments with, let's say, Counter-Strike, and then suddenly switch to another discipline, you basically must have the understanding how engine works, how you save the data, what data could be extracted, because we also had some practical problems when we attended a tournament and we didn't exactly know some specific details and we didn't manage to store some important data. Right, so we have already considered data collection, and if we have a look at data analysis and key concepts, we could basically divide them into two groups. It could be machine learning based analysis and deep learning based analysis involving convolutional or recurrent networks for time series predictive modeling. And machine learning could be useful for defining psychological in-game features that affect the performance of the player, basically for determining dependencies between different features, or find the most important and explainable features. And the second point is that you can predict the players on team future short and long term. And here it is, there could be a sub-point. Actually, you could also extract the typical behavior of athletes and even team on specific scenario. And some teams already use machine learning, some commercial products, trying to study typical behavior of their opposite teams. For example, like where they typically try to hide from another team, or what is the typical strategy for specific maps. And finally, machine learning is highly important for providing feedback and some hints for improving skills of the team and single players. Okay, so here it is again the data analytics, which could be used for game development and competitive gaming. For example, game development. In game development, data analytics could be used for intellectual content generation, for adjusting the game balance, for providing realistic and unique experience. And competitive gaming in turn is important for training, supervision, for immersion of the entertainment. And by the way, another valuable point can be the application of data analytics in scouting for talented players. No, that's all right. So, and now let's switch to particular sensors which are used in different experiments. So one of the, I would say, straightforward sensor is EEG, because I think most of you could claim that, okay, if you could measure the brain activity of each player, then you can predict and do lots of interesting stuff with it. But that's not fully true. So EEG is electroencephalogram, which shows the electrical activity of the brain emanating from neurons that generate electrical signal. And the electrical activity of neurons produces currents propagating throughout the head. So these currents reach the scalp surface in the form of changes in potential on the scalp and magnetic field, which can be measured non-invasively. However, non-invasively is not again fully true. When a player wears this EEG helmet, it really bothers players, because professional players, they are very dynamic. When they play games, they're just shaking their head. They can come closer to the display, so it's not fully non-invasive. So EEG basically measures not all electric activity, but postsynaptic potentials only. And in terms of EEG data analysis, it could be analyzed in time domain or in frequency domain, but mostly the analysis is carried out in time domain. So here it is the example of EEG rhythms. So it is like spindles of beta rhythm, 13 hertz of spindles, rhythmic delta, and here on the previous slide you could see, already filtered and quite clean signals, and this slide shows artifacts which basically make your signal not very good for further analysis, and these points, this noise like eye movements or muscle reaction or chewing or even electromagnetic situation in your lab, they also affect the measurements carried out by EEG. Right, so another artifacts like heart, sweating as well from your head, and the following technologies of headsets are available right now. There are helmets with dry electrodes, with wet gel based, and with wet water based. So basically our group, we do not carry out research with EEG. However, our colleagues, Professor Chichotsky and Professor Fan, they work in this direction quite, quickly, and they do quite extensive research. And probably, if it is interesting for you, so one of the promising directions is so-called hyperscanning or brain-to-brain coupling. So the idea is to find so-called chemistry between players and find the compatibility in the team, so that you could better shape and form your team. Another important sensor is eye tracker, and basically eye tracking is a process of measuring the point of gaze or the motion of an eye on the display. So the key idea of this eye tracker is that it is installed closely to your display, generates infrared light, and then catches the reflected light by a camera located in eye tracker, and then software just provides and engineer the coordinates of your gaze position on the display, which can be later analyzed. Right, so and when we read a text or when we play a game, there are two important metrics which you could extract from your eye tracker. So basically it is eye fixation and saccades. And for example, eye fixation metric is important in eSports because there are some situations when you play, for example, when a model, the opposite team kills you, it's important whether you had a look, whether you saw that model, and if you saw, whether you had a chance to react, whether you really react on this model or not. And this could, provide a hint how professional you are, what is the speed of your reaction. And the same is relevant to saccades. So saccades is a quick changing of your gaze on the display. And for the sake of experimentation, we conducted some tests using eye tracker. So we used the retake mode of Counter-Strike. So basically there is a team of 5 persons. There are 3 counter-terrorists, 2 terrorists defending the bomb. And the objective is that counter-terrorist team has 45 seconds to defuse the bomb. And terrorist team basically has to protect the bomb from being defused. Here it is the typical game interface elements. So you can see there is a radar, there is health and armor panel, there is a crosshair in the center of this interface, weapon panel and area of kill logs. So when conducting these experiments, we have manually divided this display, this interface on 9 zones for performing the analysis. And the next slide shows heat maps with professional athletes, the heat map of professional athletes, and with amateur players. And I think it is not visible, but basically the professional athlete spends 65% looking at the center of display, and amateur players spends just 43%. So you can see the difference is 20%. And another point that zone 2 located in left upper corner, there is a rudder, and you can see that amateur players often look at this rudder. That is why they might miss some important situations during the game. And basically professional players, they try to watch exactly in the crosshair, in the middle, in the center of the display. So each participant in our experiment is characterized by his gaze distribution vector, and each component corresponds to the zone. So then we create this sort of matrix with zones, with 9 zones, and then we use principal component analysis. So basically the gaze distribution difference for professional and amateur players. So, and it turns out that both main components are almost sparse within only one dominant coordinate, and the dominant coordinate in the first main component corresponds to the zone 1, while the dominant coordinate in the second main component corresponds to the zone 2. And here it is, the heat map results for newbies and amateur players, and you can see that really newbie players which have never played the game, so their heat map is shown on the left up corner, and professional player heat map is shown on the right bottom corner, and here it is the difference. Right, and basically let's now try to have a look at the difference of the gaze of behavior of professional athletes and newbies. So, and basically the point is that the games for individual users is absolutely another thing for these groups of players. Right, so here it is again, the heat map of professional, of just amateur player and professional athlete. And in this heat map you can, I think, clearly distinguish amateur player, because he typically looks in the rudder in the left up corner, and athlete gaze is focused in the center. So this is quite easy. You can basically even distinguish them visually, right? But what about these pictures? So can we distinguish these two players? How we can try to infer who of them is professional esports player or not? And in this case, you know, these heat maps will not help us at all. But at the same time, we have all coordinates recorded during the game, and you still have opportunity to characterize the level, the skillful level of the player. Okay, for example, on this slide you can see the calculated center distribution for the X positions of the gaze for both amateur player and professional athlete, and each has center distribution. So do you have any ideas how to classify the players and athletes? basically we can assume that the variance is the feature of proficiency.
Maybe who has any ideas how to classify them here? But I think the solution is simple looking at this picture.
Sorry?
What? No, mixture model. Maybe yes. Maybe the solution is more simple than some mixture model. Yes, because if you when you think about mixture model, maybe maybe you focus on the displacement of their means, but their means on this picture are the same. They have that is a central distribution. Their mean is 0 for both of them. So.
Okay, there is a potential answer.
No, okay, so it is not that bad, but maybe you have ideas. Maybe it's very simple as a hypothesis of this picture.
I think it's a dispersion or not. It's for the player, it's wider than for the athlete.
Oh yes, maybe I think you are right.
Okay, so basically, yeah, gaze variance is another good feature, and you can see how the players, I mean amateur players and professional athletes could be distinguished. Well, it is not really ideal approach, but still it is quite reasonably effective. Right. So what about key controls, whether we can use our keyboard and mouse as another set of sensors? So could they be helpful? So in this case, in our case, they can be really serving as a service. And here it is the figure of mouse and keyboard. So basically for shooting, the players typically use a left button, and for moving they typically use these 4 key controls on their keyboard. So probably you already know that A and D are used for stepping left and right, and for using W and S for stepping forward and back. However, there are some pros and cons about keyboard and mouse. So basically the advantages include that no extra hardware required for this experiment. So they are always on. It means they are always available for the game. The player always uses them, and you can basically do your own experiments at home. So, and another advantages include that the high-speed tracking with high frequency is possible, and basically these are the game-independent sensors. However, there are some disadvantages associated with these, I would say, amateur sensors. So first of all, it requires recording software. You need at least to prepare a Python script for recording the data from keyboard and mouse. And another point is that different players, they use different bins, different combinations. So you can actually set up in game interface your preferred combinations. That is why you should be aware of these bins when you start processing the data. And at the same time, the mouse could have mouses of different players. They could have different sensitivity. And here it is a quite simple analysis of data collected from newbies and professional players. For example, how do they work with the A and D control key? And you can see that basically professional players, they use A and D combinations not that frequently. So, I mean, no, vice versa. So they use it frequently because amateur players and newbies, they tend only using W and S. It means they just only typically try to run forward and shoot, whereas professional players, they try to, you know, do lots of steps on the left, on the right, and that is why they try to avoid some aggression from the opposite team. And another hint for the data analysis from these sensors is very specific combinations, which is shown on the right graph. And basically amateur and newbie players, they don't use this combination frequently because they simply don't know what does it mean. And upon analyzing the data, without seeing who plays, you can try to make a conclusion who of them is professional. So another point is basically how we can measure the proficiency of a player using his key dynamics. And here it is, the dynamics of just any key pressings for two kinds of player proficiency over time. So the dot means the key is pressed and empty space otherwise. And it is from real data, so we collected it from professional athletes. And how do you think what characterizes a professional player and amateur player? Any ideas?
So, as we can see here, these classes are well separated, okay, separated, but you using some left and right keys usage, but this is just a task for feature engineering, how using these pictures to propose some features, what kind of features are good for separating one class from another, because we need to test and to evaluate every professional athlete after each training, whether if it has become more proficient after training or not, whether his dynamics improved, changed. Yes, what about his dynamic? If we see some pictures, what can we do? So what will be the features that characterize the measure of proficiency of our athlete after training? So maybe so this case. Maybe you have ideas how what are the feature, maybe one or maybe more than one feature to characterize. So what is the feature to characterize? How to be say in words? What is it? To calculate what? Oh yes, for example, the occasions, yes, we got the total length for each line. Yes, maybe the total length on this picture. Yes, the total length of all red regions and the total and the sum of lengths. Yes, it is the total time. Yes, it is the total time of pressing. Yes, it is the usage of for some left and right keys, for example. Yes, it's one of the features quite well featured, as we can see on this on the bottom picture. Yes, it separates them well.
Yeah, and another idea is basically could be about the average interval length. So the duration is shorter for professional players. So and you can now see that the usage of the keys here for left and right motions separates classes quite good. However, what you can also do is to use two features, and this can provide you better classification. So you can visually see the difference, and you can group different classes of players much easier. Right. So another potential source of data and another potential good sensor is demo file, which records the video of, let's say, former battle between different teams. So you can perform this video analysis, and by the way, you can extract lots of useful data from those demo files. So, for example, you can extract in-game movement of every player. So this file also includes all game events like fight, kill, death, jump, and it can be automatically recorded by different scripts, Python scripts or plugins, and it could be rich analytical potential for machine learning. Another sensor could be thermographic camera, and basically this camera is a device which forms the heat zone's image using infrared radiation. And using this thermographic camera, you can also, try to figure out whether the player sleeps well because of their temperature of eyes. And by the way, who knows which eye is warmer, left or right, in normal conditions? Who knows? So the question is, which eye is warmer in normal conditions? Eye, yeah. Okay, so basically our left eye is warmer because it is closer to our heart. And for example, we also had some empirical studies which shown when you have a flu and when you caught a cold, the situation is vice versa. The right eye becomes typically warmer. Another important effect is called Pinocchio effect. So basically, this is the temperature at the end of our nose, and this effect could show whether a person lies or not. So you can do some, for example, tests with questions for your players and try after that figure out whether he says true or not. Right, so here it is the list of the state-of-the-art research directions. So we have lack of time, probably I won't focus on it, and moreover it is quite tough, so please take a picture. We basically identified 5 important research directions, like human-like artificial intelligence and player profiling, evolution, powered planners, data-driven game design, and others. And I would say the most interesting recently appeared research direction in eSports is effective computing, and those 2 researchers, Martinez and Yanakakis, they are world-recognized experts in effective computing, so I would highly recommend you to read their papers on how do they collect the data, how they perform feature engineering, and how do they do predictive analytics. So, and finally here it is known applications of artificial intelligence in eSports. So, for example, OpenAI 5, designed by Elon Musk company. So they started 2 years ago when they managed to win in 1 versus 1 game. After that they managed to win 1 year ago in 5 versus 5 game, in Dota 2. And this year, I think it has happened in April, they also won in 5 versus 5 game without any kind of restrictions. So this idea is based on reinforcement learning and 5 long-shot neural networks, LSTM, without human data. Right. So, and finally, I would like to demonstrate our real-time experiment on tournament. So we had a chance to participate in Moscow LAN Team Fortress discipline in the beginning of August. What we did, we used heart rate sensors, so it was like live stream with the captains of the team. So here it is, basically details of this tournament. So there were totally 42 persons, 7 teams and 6 players in each team, all of them with different skills. On the bottom you can see the set of sensors we used. So we collected keyboard and mouse data from all the players as well as voice data. We also had 2 heart rate monitors. We basically put them only on 2 persons, on captains of the teams. We also had 6 eye trackers. And we also collected different in-game statistics. Right, and here it is, again, data collection and challenges associated with data collection. And first of all, the biggest challenge is that you have to prepare data consent. So basically the players must agree to sign the paper stating that they are okay with that you collect and then use the data for research, because it is obligatory by law. So we have to just collect permission from the players who accepted to participate in our experiment. And again, when you do like field tests, you should be aware that you have enough storage, because you also collect video data, you have voice data, and you have data streams from your sensors. Right, and here it is just the summary of pulse, heart rate monitor of the teams. So the upper graph shows the situation for semi-final, and the graph shown on the bottom, the final game. So if we have a look at the final game, you can see that on the left graph, team B52, the captain had, how to say, more frequent heart rate. So in some situations it was more than 150 on the first map. And the second captain from Drippy team, and basically this team Drippy won this tournament. So it was Kalma. And by the way, this team was losing the first map, and finally, the first 2. But the point is basically that they were losing, and finally, while keeping psychological balance, they managed to win, because even the heart rate of the captain was, I would say, not that frequent. And in general, if you have just average numbers, he was Kama, then another captain. So, and if we have a look on eye tracking heat map, they are also, well, they're, I would say, maybe pretty equal, but the point is that the captain on the left from B52, so the blue heat map, so he was often looking on the bottom in the legend of this map, while the captain of winning team, Drippy, he was trying to focus his gaze in the, more or less in the center. Right, so here it is, the summary, the conclusions. Basically, I would say that esports industry and research is just emerging. It is a new area of research which involves wearable sensors, machine learning, statistics, video processing, voice processing. And by the way, you have huge and promising opportunities for applying your knowledge to this background. But by the way, for doing good research and writing good papers, you need a data set. So, and if you would like to work in this direction, we're happy to work with you if you're interested in, because we already have some data sets for further analysis. And in terms of technologies, I would say that we are, so the yesterday so-called situation which happened a few years ago, it was like dumb esports, because esports analytics was relying only on very simple statistics provided by game itself. So currently we try to use and involve more sophisticated sensors, more sophisticated, let's say, EEG components, brain analytics, video analytics, demo files analytics. And for tomorrow, we'll try to do, let's say, cognitive esports, when all this analytics will be automatically adapted to specific players and specific game scenarios. At the same time, there are lots of new research directions, such as psycho-emotional and analysis of different players, also brain-to-brain research involving EEG. And another interesting direction is mobile esports. For example, in China it is popular to play games on smartphone, and that is why if you would like to perform your analytics, your machine learning methods, it means that you should try to fit them and squeeze into embedded systems and mobile devices. All right, so basically that's it. So here it is, my contact details, and if you have any questions, feel free to ask.